Welcome back to part two of our ship to factory challenge or project. Now today, actually, in part one, we talked about making our container, okay, that holds the cylinders. And today we're not really building today, or for this video, just basically showing two things, not just one thing, but two things, because they come as a pair. So I'll leave this container right here because we're going to need it. Now, what the students have to do is they need to build a crane, a very tall crane. And the premise is that we watch a video to see how ships are unloaded, and obviously the crane they use is more of a reversed U-shaped crane. And I tell the kids that it's made of steel, so it's very, very strong all by itself. That's why it doesn't need as many cross pieces. But what we need to build is we need to build something that will lift our container up tall enough using a pulley to put it on a rolling chassis, as we call it, or a truck. But mind you, the truck doesn't have any sides or a driver or anything like that. Now, what I've done is I brought a few samples of what was made, okay? And so, for example, here is one, and I'll just take them out of the box as they are, and I'll show you a little more detail with the last one. So there's one. So what they've had to do is, this one looks very similar to a dockside crane, a dockyard crane, where they've made their rope with their hook, and they've made a pulley on top where they turn, and the two round pieces of cardboard are on there just to keep the string from wandering down the stick, or the shaft as they call it. And it has a number of cross pieces, so it's fairly strong. This will lift their load, okay, or the container. This is the part that they struggle with the most, though, is keeping it as stable as possible. And they do need a lot of cross pieces, but they need the space in order to drive the container on the chassis out somewhere else. Okay, so there's one example of what they've done. And I didn't give them any ideas of how they should make their crane. Okay, so this was a little ingenious in terms of what it did. Okay, so all they've done is made an A-frame on a piece of cardboard, and the A-frame is actually out of cardboard. And they struggled a little bit with how to design their pulley, and I think it looks like they have to do a little more work on this because I think it's coming apart. So, but I did see this one work, and it actually works fairly well. But once they put the load on it, their support pieces seem to kind of sag a little, so they do have to work on that, and they got a little bit too much tape kind of blocking the road. Okay, so there's another idea as well. And a final idea is to make something similar to our hurricane towers. Now this one, I'll take these off for now. This one is a bit different in terms that it's more of a pyramid shape, and it's really stable. It's very stable. Has a couple of straw pieces inside, so the shaft or the skewer can turn. Same principle, using the cardboard pieces to hold the string in place. And now, no matter how they build it, it doesn't matter. It doesn't matter what shape it is, but it needs to be stable enough to pick up their container. Okay, and what we've done is tied small piece of string, so it's basically to replicate, the chains or the big ropes that tie that hold on to the containers as they lift them. And all I get the students to do is just make them into a loop like this, okay, and then they just loop them in here, and they loop the loop around, right? Put it inside itself. Okay, like that, right? And then they do that all the way around. And actually, the toughest part was making these loops. That was actually hard for them. Okay, and there's that one there. So they need 4. And this one hasn't been tried, so we'll have to see if it's balanced or not. Okay, so there, now we have four strings. Okay, and what they're doing is, and there's actually a sample of this on one of the other videos on this channel. It's one of the project highlights with Marlene talking to a couple of kids who've done this project. Talking to Nicola, and I can't remember Jayan, and I can't remember the other one. But anyway, you can see it in working in that video. Now what they do is they just take their hook it up to all the strings, you know, similar to what a dockyard worker would do. Okay, because you can actually show them the videos of how these chains are hooked up to the containers. Mind you, it seems a little more simple when they do it. Okay, and then it turns around and the string should hold in place and it should lift it up reasonably well. Yep. Okay, and it lifts it up like that. Okay, so now they have to drive their rolling chassis or truck inside. We're going to talk a little bit about this after. They have to drive the rolling chassis in, okay, and if they have bumps in here, that's fine. If they have to go over a bump, that's okay too, because in the real world that does happen. And then it lowers down like this, okay, and then they unhook it, and they can just leave the strings on. That's fine. It doesn't matter, or they can take them off once it comes off, and then it comes out of the crane, and it drives off to wherever the destination is, whatever factory or what it might be. You know, like I said in the other video, hundreds or thousands of kilometers away, right, to the factory. Now, the one thing they have to remember when they build their cranes is that it needs to be tall enough for this to be able to go in and out. Okay, if they make their cross pieces too low, it won't fit. It won't be able to drive in. So for example, I think I can just barely get it out this way. So it can go this way as well, and that's fine. Okay, so I actually am able to go both ways. So this one's designed reasonably well. Okay, so that's good. Now, if I take this off, the other thing they need to be reminded about is the distance. Okay, these skewers are actually much longer, and I do try to remind them that their structure needs to actually fit the truck, because if the truck can't get in, then they can't get the load off and make their money and get it to the factory. So they have to design the shape with the car or the chassis in mind, and what size they want it to be. And one thing to lead them towards is the idea that the chassis only needs to be as big as the container, so it fits on almost exactly right. And we did talk a lot about why it should only be the size of the container, why not bigger, what happens if it's too small. So we talked about costs and the amount of steel used, and maybe the fuel efficiency on the road if it's, you know, a nice tight small size, and also the maneuverability of it being able to maneuver on the dockyard and also at the factory when they have to unload it, which is the next video. And to make the cars are really simple. If you want a lot of detail on this, just go to our balloon car video, and it shows you the basics of the chassis. However, this one's a little different though, because what they've done is they've shortened the straws. Okay, they've shortened the shaft, okay, and the housing on this. So they shortened the shaft, and the axle is also shortened too. So it's the right width to go in and out. And the other trick to this one is they've added more wheels. I don't necessarily want to take this off, but no, I'm not gonna. On this one, in the balloon cars, if you watch that video, you'll notice that there's just one circle on it, one cardboard circle. On this one, they've put 4 circles on each. okay? And that's just to make it a little stronger. And I asked them what they think if they should glue the cardboard wheels together and make it one big piece, or just leave it the way it is. And it was kind of a 50-50. Some had really good ideas. Some said it should be closer together so it's stronger. Some said it shouldn't be tied together because if the wheels spread apart a little more, it'll give it more stability. So as long as they can explain why they're doing what they're doing, that's great. And this one has chosen to just leave it not glued together, so to keep them separate, which I think works as well. Both ideas work just as well. Okay, but the size of this is very important because this depends on it. Okay, so each one of these projects, they've determined already what size they want their chassis to be. Okay, they've already said, I want my chassis to fit inside, so it has to be this big. So they've kept that in mind when they're building the crane as well. So technically, I guess you might want to build the chassis first, so it fits this exactly. If I was to do it again, that's probably what I would do. I'd say, okay, build your chassis the exact same size, or the exact size for the container. I think that's what I would do if we were to work on it again. Probably next time, that's what we'll do, and then build the crane so that they know exactly what size it's going to be to minimize the size of this. But the basic part of this, though, is the structure itself, how stable it is. That's a big part for the grade 4 group that we're working with. And the other big one is the pulleys. Right? Everything we do involves pulleys with this. So that's part of what they have to make as well. Okay, they have to figure out how to lift it up, how to make a little pulley to lift it, a little hook at the bottom, and the distance is important as well. Okay, so the next video, we are going to talk about the final step in this challenge, which is to make a rotating crane. Because once it gets to the factory, these containers need to come off the truck. And the next thing is a rotating crane. And we have a very cool method a very simple method to make one of those. Okay. Hope you enjoyed today's video, and we'll see you again for part 3. Thanks.